This is Brimley Newton with BNL Consulting, and in this video I'll be showing you how to run the BNL SAS Code Analyzer against an existing log file. The first thing we want to do is deploy the SAS code to the SAS application server. I have my zip file here on my desktop, and I've also got a projects folder called SAS Code Analyzer that exists on both the client machine and the application server. This is where I'm going to be putting the SAS code. So I'll go ahead and paste my zip file here and unzip it. And then we can delete the zip file as it's no longer needed. And so here we can see I have 4 new folders. Analysis results. This is where all of our HTML data is stored. This includes the graphs that are created by the application. Data. This is where the actual data on the logs exists. Logs. This is a folder where any temporary logs are stored. And SAS code stores all the SAS code and macros, as well as the SAS configuration files if they exist. Here you can see I already have some existing configuration files as well as an existing log. Now that we've deployed the code, let's go ahead and take a look at the existing log file configuration. At the top of this file, you can see that we have a description of each of the variables. Base drive is used to define the root of the project. The log file to parse. This is going to be the log file that we're parsing, essentially pulling statistics from. It's important to note that when you ran the program that initially created this log, that you have the full S timer option set. This way you get all the data provided by SAS and not just some of it. The log file folder. This isn't used if you're running across an existing log, but it's used to store temporary log files. New performance log also isn't used if you're running over an existing log. This is used to create a temporary log when running inline. Append. This is used to determine whether or not the data set that's created from the statistics pulled from the log is appended to or is recreated. You'd want to append to the same log if you'd want to compare 2 different runs, essentially 2 different log files from the same program run at different times. This way you can compare any changes made to the application. The output data directory, this is where the data sets are stored. The output data member is the name of the data set. The output graphics directory is where essentially the graphical results get stored. Measurements, we're not going to be using. Run analysis request is used with the append equals yes option, which we are not currently using. SAS program and execute program are used when executing a program inline to be analyzed. As we're not using those, we're going to leave those as is. So we'll go ahead, we'll go to our SAS code folder, code. Let's go ahead and open up SAS Code Analyzer. Here we need to define the configuration file we're going to be using. And we're going to be using existing_log.conf. So now that we've got all the variables set and in place, we're going to be parsing this log file that we've already created. You can scroll through here. The first thing it does is it pulls the configuration file and assigns those variables. This portion is used for if you're executing it inline, as we're not. And then this portion is where it actually executes the code and derives some basis statistics. So we'll go ahead and run this. And you can see here that we get the statistics back. So we get a summary. This is kind of useful to give you the minimum and maximum kind of some basic information. And then the first set you get the top 99th percentile graphs. This essentially means that these steps shown here take up the top 1% of elapsed time. So you can see here we had one data step that took 30 seconds. And then the graphs change based on the operating system value. So we also have system time, operating system memory, step count, block output parameters, page faults. And then the next set of graphs essentially shows all the data steps and all the proc steps. So essentially this is useful to kind of see an overall view of your program. So you can see here at the beginning we had a lot of programs or a lot of data steps or proc steps that took a long time. Then we had quite a few relatively short ones, a small spike here in the middle, and then spikes here at the end. This is where it's actually appending data to a MySQL database. And there are just some basic, some other basic operating system values included here. System time, user time, observations read, written, and variables written. Something to note is that if we had multiple log files, we could have gone in here and added a space and added another log file. And it would have gone over each log file in succession. And that's going to be it for analyzing an existing log.